can you turn your industrial equipment program into a profit center instead of simply costing you money? How can you keep your equipment running longer, even when you work it hard and put it through the ringer?
We will deal with these questions and much more on each episode of Maintenance Shop Talk, a podcast presented by ExxonMobil.
I'm your host, Michelle Siegrist, and today we're focusing on hydraulic systems, some of the hardest working machines in any plant. My guests are Michelle Ruiz, a lubrication engineer with ExxonMobil who spends most of her time on the plant floor. I would also like to welcome Ken Bannister, an engineering consultant and published author on industrial maintenance. Ken and Michelle, welcome.
Good morning, Michelle.
Good morning.
It's great to have you both here. So let's get right to it. As we all know, hydraulic equipment designs have changed a lot over the past 10 years, and systems are getting more compact, but they're also able to deliver more power. And as a result, we're seeing more intense operating conditions. So can you guys describe for us these conditions and also discuss how they impact equipment performance?
Well, I'll start the questions. When we look at the smaller, more compact systems that are in place these days, one thing has changed considerably from the past, and that is the tolerances in the equipment are much more critical and closer, which affects the oil viscosity requirement. So the correct viscosity is very crucial in this regard. And also, when we're talking about that, is the contamination of the fluid, which will have an impact on the actual system itself. With closer tolerances, it's less dirt tolerant, and if there's any dirt contamination in there, it will score the bores and start to leak much quicker than before and lose power as a result.
Yeah, from a lubrication end, when we're talking about smaller reservoirs, the first thing we should think about is higher temperatures. And if you think about your lubricant going through higher temperatures because you have less resonance time, less time to cool, you're basically cycling the fluid a lot more than you would with a larger reservoir. You're talking about more wear and tear on the oil. So if you think about how that impacts your equipment in a hydraulic system, maybe think back to some of those sticky valve situations where you're oxidizing oil, and along with some of the anti-wear packages that fall out and form deposits, you're starting to see an impact on production.
That's crucial. So what can operators and lube technicians do to protect their hydraulic equipment?
Well, Michelle, there's a lot of things they actually can do in terms of ensuring that breathers are in place and the correct type of breathers are used, like a desiccant breather, not the old style of breathers. We also look at polymeric filters, which collect the water and hold the water in the filter if there's any water contamination, and transfer protocols. So transferring lubricants, ensuring that the lubricant that you're transferring in stays clean while it's being transferred. So there we have specific types of fittings where they're closed fittings, a closed loop system to transfer the lubricant into the reservoir, ensuring no outside contamination gets in. So again, it's protecting the equipment through putting a barrier up to not allow contamination to get into the reservoir that can cause problems.
Okay. I would like to dive a little deeper into the actual role of the lubricant and how does that help to protect the equipment?
Yeah, I'll jump in on that one, Michelle. So
Great.
the lubricant has a couple of different roles, right? The first thing we think of is it's supposed to protect metal to metal contact. But then we also think lubricants are meant for heat transfer control, for preventing rust and corrosion, for removing contaminants. So really, when you're talking about how lubricant can protect your equipment, the first thing you want to think of is, am I using the right quality of lubricant? So is this a type of lubricant that I've selected going to withstand the types of temperatures and pressures that my system is going to need to run through? The one thing I'd recommend is definitely, equipment builders use their lubricant suppliers to run tests on different types of lubricants. And earlier, Ken mentioned viscosity. That's one of the most important parts of a lubricant. These are the types of properties that equipment builders will test on their equipment, and they'll put little tags or recommendations in the owner's manual that will tell you exactly what types of lubricants to use for the best type of protection.
Yes, I can see how that would be so helpful and also critical. And in addition to protecting the equipment, these lubricants also help us push the equipment harder and, in effect, can reduce some costs. Is that correct?
Well, there's the costs that you would likely save in these types of systems by using the correct lubricant is energy. Energy costs, as we know, are becoming very prevalent and on the rise continually. And one thing that you don't want to have happen is to have the systems leak. A leaking system is an inefficient system, and if there's heat transfer build up as a result of friction or as a result of the wrong lubricant being utilized, we get energy losses as a result. So that's one big area. And I guess that's one of the topics that will be coming up in the future. We'll talk more about the energy side of it.
So Ken makes a really great point on energy, but then I like to take a step back and look at production as a whole. And you think about energy reduction, that costs money. You think about certain types of lubricants extending your drain intervals, that saves you on downtime, right? Because now the lubricant's lasting 3 times longer. You don't have to change out the lubricant and you don't have to bring the machine down and not produce. Then you don't have to pay for disposal of lubricants. There are a lot of different implications, kind of like the tip of the iceberg. And there are so many implications from a production standpoint that come into those cost savings.
That's great. You both talked a little bit earlier about the importance of matching the lubricant to the equipment and to the application. So let's talk a little bit about the lubricant characteristics that operators or maintenance managers should look for when they're choosing an oil, and also how do these properties interact?
Sure. So, one of the things that you should look at when you're selecting a lubricant is what kind of operating and ambient conditions is it going to be going through. So, we mentioned a little bit earlier, is it going to be in a really hot environment? Is your hydraulic system in a foundry and it gets covered with a nice insulating blanket of sand? Those are the types of things you want to look at. And then when you make your decisions, you want to look at some properties in the lubricant itself. And one of the ones that are my personal preference to look at is the viscosity index. And for those of you that don't know what viscosity index is, it's basically an index that tells you how does viscosity change with temperature. And ideally, you don't really want it to change with temperature because when the manufacturer specs it out with a specific type of viscosity, you want to stick to that type of recommendation as much as possible. But before I jump forward, the higher the viscosity index is, the better. But one thing I would caution decision makers out there is to make sure that when you look at a high viscosity index, if it's too high, ask more questions. Many times, really high viscosity indexes have added modifiers that improve that number, but might not be what we call shear stable. So you definitely want to start talking about shear stability because you might be operating at really low temperatures or high temperatures, and this high viscosity index will help you very much. But if in a couple of weeks you don't really have that high of a viscosity index because it shears down, then you're not really getting what you wanted to get in the first place. And I guess the one more thing I'd recommend on that sense, you kind of want to take a look at mineral and synthetic as well, depending on those temperature conditions. And one of the things that we've discussed before is the kind of rule of thumb that we use out in the field, which is above 140 for a mineral oil, every 18 degrees Fahrenheit that you go above that 140, you basically half the life of a lubricant. On a synthetic, that starts at 170. If you look at those conditions, you definitely want to take that into consideration.
I think they call that the Annus Renis rule, isn't it, Michelle?
Yeah.
Well, that's really interesting. And you hit on something that I just want to explore quickly. You said that sometimes these conditions can change. So is there a certain amount of time in between intervals that you should check these things? Because if the conditions are changing, then maybe the lubricant must change as well.
Yeah, I would say you probably don't have to worry about it throughout the life of the lubricant. I mean, you definitely want to be tracking those changes with oil analysis, which I think we're going to talk about a little bit later. But really, you just want to put in as much investment of your time into picking the right lubricant that's going to have a good balanced formulation. So that means that it might be really good at temperature control, but maybe it's not very good at keeping that temperature control characteristic. Or it might not be really good at foam release, right? So you really want to do your research in the beginning and make sure you invest correctly to something that's going to be able to withstand. So you don't have to be checking and changing so often.
So making the extra effort on the front end to choose the right lubricant at the right time is going to make a difference on the back end.
From a practical sense on that, Michelle is absolutely correct. Choosing the right lubricants is critical. And one of the things from a practical application is a consolidation program, which we try to take companies through almost immediately. And that's understanding what lubricants they have in their plant currently. And you'll find there's a lot of redundancy and a lot of lubricants that were bought as one-offs that weren't tested correctly in the plant. And the chances of cross-contamination as a result are huge. So the first effort is to take stock of all the lubricants that we do have. And you work with companies, people like Michelle, actually. She's the right kind of person that you'd want to work with, say ExxonMobil, or choose a vendor and help them come together to say, okay, what lubricants are good for the applications and the ambient condition factors that we have in our plant specifically. And you can find out that normally most plants have around between 10 and 25 different lubricants sitting on their shelves, of which perhaps 4 or 5 actually will cover 80-90% of their needs within the plant. So that's
Sure.
the role that the lubrication companies such as ExxonMobil can help you consolidate your efforts, bring it down, and then we're dealing with less SKUs, less cleanliness issues in terms of cross-contamination of the products within the plant as they're applied, and storage and transfer of the equipment is greatly reduced, costing you less money and making it easier for the operator to actually make their choices.
Well, that is wonderful advice. And from your experience and expertise, I'm sure that that is going to be helpful to our listeners. I want to dive in a little deeper to, we talk a lot about aging infrastructure and aging facilities, and there are a lot of older facilities and older equipment out there. So lubricants certainly make sense for newer equipment, but what about this older equipment? And does the lubricant choice matter as much in that scenario?
I guess from an application perspective, one of the things that we really need to do in any plant, it's very rare we get a brand new plant to work with. It's usually more aging equipment and keeping that equipment going. But that being said, a lot of companies can do that very, very well. And it's about getting your equipment in order first and understanding what that equipment is supposed to do. So part of reliability engineering is to understand what the equipment capability is and not to overstep that bound in regard asking it to do 120% of what it was designed to do. That's going to cause you problems on all of your systems. But if we have good maintenance practices, GMP, and we practice that, we can do a lot of things in keeping leaks under control, getting the right lubricants in place, keep the lubricants clean, the transfer protocols, all are good maintenance practices. And if you get those in order, this will allow you to use advanced lubricants and better quality lubricants so as we're not wasting the advantages that you get by allowing them to leak through the system.
Yeah, you can always ask your supplier to perform a hydraulic fluid index study. I'm sure you know about that stuff, Ken, but basically your hydraulic fluid index is just a good way to understand how much you're leaking. So how much are you topping off every year throughout your hydraulic systems, and what is the capacity? So the full reservoir capacity of all of your systems. And if you're below 10%, you definitely want to invest in a good oil that's going to last as long as possible. If you're between the 10 and 30%, that's when you want to start doing the balancing act of how much is it worth it? Is it better if I can consolidate? What is it worth for you? And if it's above 30%, that's what Ken was talking about. Maybe it's not worth the bang for the buck.
Sure. And I'm wondering, what is the average lifespan of a lubricant?
Ooh, that totally depends on your oil analysis.
I'm sure it varies according to the application and the equipment that's being used, but so maybe
And
that
the
wasn't a
ambient
fair question.
condition factors that they're working under, whether it's dirty, whether it's a clean. Like, for instance, if you were in a pharmaceutical plant with HEPA filters, it's almost like a white room or a clean room versus a foundry, which is very dirty, sand, heat, moisture. The lubricants will perform differently in both environments. As Michelle alluded to much earlier in our conversation here, she talked about ambient condition factors, and that's very important to take into consideration.
Okay,
Oh,
what
yeah, for sure. And it depends on the type of oil too, right? That's why I'm a really strong believer in oil analysis. You remember I talked about those lubricant equipment builder tags? Sometimes those tags recommend, hey, change out your lubricant every 6 months. And that's really when you go back to that cost question. If you change it out every 6 months, you might be throwing away really good oil. But if you take a look at your oil analysis and do full-fledged analysis on it, 2 to 3 times a year, then you can extend that life way past 6 months. I mean, I'm talking years.
And that's
wonderful.
condition-based maintenance at that point, isn't it? You're changing based on the condition of the lubricant in its actual working environment, which is absolutely bang on.
Good. So, are there other tools and services in addition to choosing the right oil and using the right oil that operators can implement that will help them to squeeze more life out of their hydraulic machines and more performance?
Oh, for sure. I like to say that lubricant, hydraulic oils are like the lifeblood of your equipment, right? So there are certain things you do to your own blood and to your own body to stay healthy. Same thing here. So, as I mentioned earlier, oil analysis is definitely the way to go. It helps you extend the life of your oil, it helps extend the life of your equipment. And really importantly, from a downtime perspective, It helps you understand whether or not something's about to fail just out of age or because of contamination, and you can act preemptively before you have a reactive situation where you're down without scheduling. Then there's also lube tagging, so putting the right equipment and lubricant name on the equipment and on the transfer equipment. That helps prevent mistakes such as putting a gear oil in a spindle and causing some crazy downtime. And then I know checklists have been really helpful at my customer sites. I know we put together recently at a mining equipment manufacturer in the Milwaukee area a big checklist on how to take a good oil sample in order to prevent contamination and really get a good idea of your system. And I know Ken actually is writing a book that incorporates kind of how to do checklists with maintenance. Do you want to talk about that at all, Ken?
Yes, absolutely. I mean, checklists have been around for a long time and have been proven to be very effective for aircraft checks. And thank goodness they do that, right? Because we want to make sure that when that plane's up in the air, it actually comes back down in one piece. So,
I'd like that. Yes.
And then that was followed. There was a gentleman called Atul Gawande who wrote a book called The Checklist Manifesto. And that was based on the World Health Organization looking to utilize the checklist in aircraft and for doctors and nurses so that we would ensure that the right person was getting the right operation at the right time. And what we've done in maintenance, we've kind of adopted that style, which is a checklist. So we don't want to tell the tradesperson exactly how to do something. I mean, they're trained for that, but we want to make sure that they do it in a consistent manner. So no matter who we send to have perform the work, the check is performed and the job is performed in the same way consistently every single time. And that really is about good maintenance practices, is consistency in terms of understanding what you're looking at visually, so as you understand if there is a problem and that problem needs to be addressed. For instance, looking at things like filters, make sure the filter hasn't gone into bypass mode, allowing all that dirt to go directly into the system. Was one way. Are the desiccant breathers, if you're using a desiccant breather system, as the color changed, so they need to be replaced. So we're looking for condition again, as Michelle was talking about before, and of course the oil analysis, as Michelle has already talked about. So we can do things like that. And then there are things based on the operation itself, which can cause problems. For instance, the raw materials raining down on the hydraulic systems. It's just a shower of dust and debris, or maybe we're using water to clean out, say, in food processing. Well, we want to ensure that the lubrication systems are not rained down on with dirt or with water, which can ingress the system through the seals. So building simple deflection guards and looking at your situation individually and following through with that and being consistent in your methodology and how you approach your equipment.
Well, that is fantastic. I want to thank both Michelle and Ken for your time and expertise, and we look forward to speaking with you all on future episodes of Maintenance Shop Talk,
a podcast presented by ExxonMobil. And for more information on energy efficiency, there's so much out there. Be sure to visit mobil.com/podcast. Thanks so much for listening.